So this slide summarizes from weakest to strongest the 802.11 security. 802.11 security uses static WEP. That's where 802.11 security ends. But the fix to 802.11 security and the weaknesses of WEP is 802.11i, which adds to 802.11 dynamic WEP, still fraught with many weaknesses and vulnerabilities, but an improvement over the old static WEP. But then we get to the real full-blown 802.11i using temporal key integrity protocol. Again, based on RC4. Again, it's simply a firmware upgrade for virtually all 802.11 hardware, and it solves all the problems that WEP introduced. So it is a relatively strong security protocol for wireless networking. However, it is temporary. It will be replaced with WPA2 or Robust Security Network, RSN. This uses the AES Advanced Encryption Standard with CBC MAC and counter mode protocol that solves in a very strong fashion all the security issues related to wireless networking. We will all eventually need to get to this WPA2 or RSN that uses the AES with CCMP. So WPA, the low end of 802.11i, uses TKIP, Temporal Key Integrity Protocol, that rotates the keys on a regular basis. Temporal meaning temporary keys that get rotated. Now TKIP uses what's called pairwise master keys. This means this is a pair of keys between a supplicant and the access point, so that a second supplicant has his own pairwise set of keys with the access point separate from the first guy, so that no matter what data is transmitted between supplicant number 1 and the access point, any other supplicant in the cell is not able to decrypt those frames. So I have a specific and discrete pair of keys between the access point and each supplicant. So a different key pair for each supplicant, so that your data frames are now all encrypted securely, strictly between supplicant and access point. There's also a group-wise master key, so that every node in the cell can decrypt the broadcast frames. So the group-wise keys are used for broadcast. Every client in the cell uses the same group-wise key, so that when one guy broadcasts, all the other guys that have the same group-wise key can decrypt that broadcast and understand what the broadcast is about. Again, these keys get rotated on a regular basis using something called broadcast key rotation, or BKR. Again, this is all part of the Temporal Key Integrity Protocol. The RSN, which is the high end of 802.11i, is equivalent to WPA2, and it replaces TKIP with the AES, Advanced Encryption Standard, based on the Reindahl algorithm. Again, it uses CBC MAC with counter mode protocol, and again, it rotates the keys. It also uses the pairwise and the groupwise keys that get rotated on a regular basis. Again, we will all need to eventually rotate to the Robust Security Network, equivalent to WPA2.